in the moment you lift your eyes to the night sky. Have you ever felt like a tiny grain of dust drifting through an endless ocean of space? How big is the universe? A question that seems simple, yet hides a promise of a journey unlocking secrets that light must travel billions of years to reach. Tonight, we let science whisper like a meditative song, letting the universe appear as a gentle being opening its arms and inviting us in. If you cherish quiet moments filled with trembling wonder, leave a like and subscribe, like lighting a small star to keep this voyage glowing. And now, before the first door opens, ask yourself, what awaits us in the questions about the scale of the universe? When we explore the scale of the universe, we are not just dealing with numbers or distances, we are confronting the limits of the human mind. A simple question like, how big is the universe, becomes a doorway into the deepest mysteries of existence. The moment you lift your eyes to the night sky, you stand at the edge of understanding a cosmos so vast that even our boldest imagination struggles to keep up. The universe we see, our observable bubble of space, is already 93 billion light-years across, a size that defies intuition. Carl Sagan once said, "The universe is not only stranger than we imagine, it is stranger than we can imagine." And those words ring even truer today. We are trying to comprehend scales that dwarf our planet, our solar system, and even our galaxy. What we call the cosmic scale is not just large, it is overwhelming. Distances in the universe seem impossible because they operate on a completely different logic from our daily lives. Light, the fastest thing we know, takes billions of years to cross what amounts to a small corner of the cosmos. And that light must thread its way through a landscape shaped by dark matter, accelerated by dark energy, and stretched by an ever-expanding fabric of space-time. The universe is not static. It grows. It breathes. It pushes galaxies farther apart in a silent drift that has lasted for nearly 14 billion years. This leads to one of the strangest truths in cosmology. The universe is 13.8 billion years old. Yet the observable universe is 93 billion light-years wide. Inflation, the rapid growth of space in the first fraction of a second after the Big Bang, pulled everything apart faster than light itself. Not because anything traveled faster than light, but because space expanded beneath it. Even Einstein would have been startled by how far his equations could stretch. And still, what we see is not the whole. Our cosmic horizon, our true boundary of knowledge, is not a physical edge. It is simply the farthest distance from which light has had time to reach us. As Sean Carroll remarked, the horizon of what we can observe is not the horizon of what exists. Beyond what we can see, the universe may continue endlessly. It may be hundreds of times larger. It may be infinite. Infinity is a terrifying yet beautiful idea. If the universe is infinite, then every possible arrangement of atoms must occur somewhere. And that includes you. Somewhere in the vast darkness, there could be a version of you watching this same video. Another making different choices. Another living a completely different life. Max Tegmark put it simply: If the universe is infinite, somewhere there are exact copies of you. The thought is both poetic and unsettling. This question naturally leads us toward the possibility of a multiverse, a reality where countless universes expand like cosmic bubbles, each with its own laws of physics, its own galaxies, perhaps its own forms of life. Some universes might collapse instantly. Others might flourish. Some might look uncannily like ours. If eternal inflation is real, then these parallel worlds are not fantasy. They are a mathematical consequence of the way space-time behaves. Look deeper, and the universe reveals patterns that mirror our own biology. The cosmic web, the large-scale structure of galaxies, looks eerily similar to neural networks in a brain. It forces us to wonder whether consciousness and cosmic structure might reflect a deeper principle shared across scales. Perhaps the universe is not only a place where consciousness arises. Perhaps the universe itself has a form of awareness slowly waking through the minds that study it. Some scientists go further, suggesting our universe may be a projection, a hologram, or even a simulation built by an intelligence far beyond our own. And the difficult truth is that we cannot prove these ideas wrong. Our limits of knowledge are not failures. They are part of what makes the quest meaningful. As someone who has spent years peering into the depths of space, I have come to believe that the true grandeur of the universe lies not in its size, but in the transformation it awakens inside us. The immensity of the cosmos humbles us, yet somehow it empowers us. It reminds us that we are small, yet capable of thinking beyond ourselves. Einstein captured this beautifully. The most beautiful thing we can experience is the mysterious. In the end, every question we ask about the universe is also a question about ourselves. When we ask how big the universe is, we are really asking how far human consciousness can reach. When we wonder whether there are other versions of us, we explore the borders of identity. When we consider the possibility of simulations or multiverses, we challenge the very nature of reality. The lesson the universe teaches is simple. Understanding is not a destination. It is a journey. We were not born to grasp the whole cosmos. We were born to reach for it. And in that reaching, in that spark of curiosity, we become something extraordinary. The cosmos is vast, but so is the human mind that dares to measure it. When we drift into the quiet depths of the night sky, we often imagine the solar system as a crowded neighborhood. Planets spinning in elegant circles, moons dancing in orbit, comets gliding like frozen lanterns across the dark. But the truth is far stranger, far lonelier, far more beautiful than the intuition of our small world suggests. The solar system is mostly emptiness, a cathedral of dark space so huge that every planet could be placed inside it and still leave room for thousands more. Astronomer James Jeans once whispered into history, "The universe begins to look more like a great thought than a great machine." And in the stillness of this cosmic cathedral, that thought becomes almost audible. Imagine standing on a grain of dust, because that is what Earth truly is when measured against the vastness of our own sun. Now imagine that sun shrinking into a tiny glowing bead in the enormous dark void between stars. The distance between stars is not measured in miles, but in aching silence, in stretches of nothingness so vast that light itself needs years to cross them. Stars are separated by millions and billions of times their own diameters because the universe was not built for closeness. It was built on a cosmic scale, where distance becomes part of the architecture of existence itself. This is why even our Milky Way, which feels enormous to us, is only an average spiral in the observable universe. Carl Sagan once said, "Our galaxy is one of 100 billion galaxies." And that was before we discovered that the number might be closer to 2 trillion. In the quiet of a winter night, when the sky feels full of stars, it is humbling to remember that what we see is not even a fraction of what truly exists. And then there is IC 1101, a galaxy so vast that it defies language, stretching more than 50 times larger than the Milky Way. If our galaxy is a swirling island of stars, IC 1101 is a continent, a luminous empire, a golden storm of suns sculpted by cosmic expansion and the invisible pull of dark matter and dark energy. These two unseen forces shape the universe like tides shaping a shore, drawing galaxies together, pulling them apart, weaving them into forms that no human hand could ever design. And yet, galaxies do not float alone. They cluster into families, small groups bound by gravity. These groups gather into clusters, then into superclusters, and eventually into something wondrous. A vast, interconnected network known as the cosmic web structure. Seen from afar, the universe resembles a glowing brain, filaments of galaxies stretching like neural pathways, clusters acting like nodes of thought. Physicist Franco Vazza once demonstrated that the mathematical patterns in the cosmic web and in the human brain are astonishingly similar. So much so that he wrote, "The universe looks like a scaled-up version of the networks inside our minds." It is a comparison that lingers, because it hints at a question as old as philosophy itself. Could the universe possess something like a mind? A form of cosmic consciousness that evolves as structure emerges. This is speculation, not science. And yet it feels strangely appropriate when the largest patterns in the universe mirror the architecture of thought. As we drift through these scales, from planets to stars, from stars to galaxies, from galaxies to the web itself, it becomes natural to wonder why the universe is built this way. The answer lies partly in the aftermath of Big Bang and inflation, which expanded space so quickly that matter could only collect in certain regions, forming filaments, leaving voids. Gravity then sculpted these filaments over billions of years, pulling matter along, invisible threads woven by dark matter. You and I exist in one tiny intersection of this cosmic tapestry, a single luminous stitch in a fabric that spans billions of light years. And yet, all of this structure exists inside a boundary we cannot cross: the cosmic horizon. It is the limit of what light has had time to reach us, not the limit of the universe itself. Beyond that horizon, there may be billions of other galaxies, entire regions of existence we will never see. Stephen Hawking once reflected on this when he said, "The universe is not only stranger than we think, it is stranger than we can think. And if the universe extends without end, then we enter the realm of infinity in cosmology. An idea that stretches the mind like a flame stretches a shadow. Infinity forces us to confront the possibility that the universe may repeat itself, that patterns recur, that somewhere, another you may be moving through another world. This is the domain of multiverse theory, where inflation might have created countless bubble universes, each expanding into its own destiny. Some scientists propose that if these universes exist, we might be living in one of infinite variations, a thought that is at once liberating and disorienting. Others go further, suggesting through the simulation hypothesis that our cosmic web might be the visible pattern of deeper information processes, like the rendered surface of a much larger reality. If this is true, then structure becomes a clue, a footprint, an echo left by the architecture of the underlying code. Still, even the boldest ideas come against the same immutable wall, the limits of knowledge. There are things we may never measure, horizons we may never cross, structures we may sense but never touch. And perhaps that is the beauty of it. As I reflect on the cosmic structure that shapes every star and every void, I find myself amazed not only by the universe, but by our capacity to think about it, to look at a night sky and wonder why it is built the way it is, to ask questions about scales that dwarf our tiny lives, to imagine patterns far beyond our reach. This is not a small achievement. My own belief is simple. The universe teaches humility through size, but it teaches meaning through curiosity. Its structure reminds us that even in a cosmos of unimaginable immensity, consciousness can bloom on a small blue world and dare to trace the outlines of creation. Einstein once said, "The eternal mystery of the world is its comprehensibility." And perhaps that is the lesson we carry from the galaxies and the cosmic web. The universe is vast, but it is also knowable, and we, brief sparks of awareness, have been given the extraordinary privilege of trying to understand it. If you want this rewritten as a whisper-slow bedtime narration or trimmed for a 5-minute video segment, just tell me and I'll shape it exactly to your style. When we look back across the history of the universe, we are really looking across the history of everything that has ever been possible. The cosmos is not a static picture. It is a story, a quiet unfolding of space and time that has been expanding since the moment of creation. And yet, in that vast, quiet expansion, there are mysteries that stretch the mind until it trembles at its own limits. One of those mysteries is this: how can a universe that is only 13.8 billion years old contain galaxies now 46 billion light-years away? It seems impossible at first, like watching a child outrun their own shadow. But the secret lies not in the galaxies themselves, but in the fabric beneath them. Space is not merely an empty stage. It is a living structure, a surface that stretches and expands with every passing moment. This is the heart of cosmic expansion, the idea that distance can grow even when nothing is moving through space at all. Stephen Hawking once said, "The expansion of the universe is the most important discovery of modern astronomy." and it continues to reshape how we understand everything beyond our planet. Imagine two galaxies drifting apart, not because they are flying away from each other, but because the space between them is quietly increasing in size. In such a universe, light becomes a messenger, struggling to cross a river whose current grows stronger every second. Even if a photon began its journey billions of years ago, the distance it needs to cover may have doubled or tripled before it ever reached us. This is why the observable universe is so much larger than its age suggests. People often ask, if space is expanding, then what is it expanding into? It is a question that feels natural, yet it reveals how deeply our intuition is tied to the spaces we have lived in. A balloon expands into the room around it. A wave expands across the surface of the sea. But the universe is not expanding into a larger container. It is expanding into itself, creating more space where there was none before. As Alan Guth, the father of cosmic inflation, once said, "Space is not expanding into anything. It is simply getting bigger." This brings us to the Big Bang and inflation, perhaps the most misunderstood idea in all of cosmology. The Big Bang was not an explosion in space. It was the expansion of space itself. There was no center, no shockwave, no fiery ball tearing through a pre-existing void. Everything expanded together, every point rushing away from every other point, like the surface of a balloon inflating from nothingness. Inflation, that brief and extraordinary phase in the first heartbeat of the universe, is even stranger. In less than a trillionth of a second, the cosmos grew exponentially, faster than light could hope to travel. This does not violate relativity, because nothing moved through space faster than light. Instead, space itself simply changed scale. And this sudden stretching explains another puzzle: why some regions of the universe are so far apart that even light will never bridge the gap. There are galaxies today that recede from us faster than the speed of light, not because they are breaking cosmic laws, but because the space between us and them expands endlessly. Light chasing these galaxies is like a runner on a treadmill that keeps speeding up. In this endless chase, we arrive at one of the deepest concepts in modern cosmology: the cosmic horizon. It defines the boundary between what we can know and what lies forever beyond our reach. It is not a wall, not an edge, not a limit of reality, but a limit of perception. Beyond that horizon, the universe continues unchecked, but no message from those realms can ever reach us. Brian Greene once reflected, "Most of the universe will forever remain outside our grasp." And he meant it literally. This is the first great lesson of cosmic history: that even with perfect instruments, perfect theories, perfect technology, there will always be a horizon we cannot cross. It is a reminder of the limits of knowledge, one we must learn to embrace rather than fear. Yet, as the universe expanded, it also began to form structure, delicate patterns woven from gravity and heat. These patterns eventually grew into galaxies, clusters, and the vast webbing we call the cosmic web structure. The early temperature ripples in the cosmic microwave background told us this story with astonishing clarity. Tiny fluctuations that would one day become entire constellations. The universe remembers its childhood, and we can still see those memories, frozen in its oldest light. But with expansion comes loneliness, and with loneliness comes wonder. If regions of space drift apart forever, if countless galaxies slip beyond view, what lies beyond them? This question leads many physicists toward the possibility of other cosmic domains, entire realms outside our horizon, perhaps governed by different laws. This is the seed of multiverse theory, the idea that our universe may be only one bubble in a vast foam of inflating space. It is a radical idea, yet inflation almost demands it. If inflation can happen once, it can happen again, and again, and again. And suddenly, our cosmic history becomes just one chapter in an infinite library of possible histories. At the philosophical edge of this lies infinity in cosmology, a place where imagination collapses under its own weight. If infinity is real, then everything that can happen must happen somewhere, perhaps even an infinite number of times. Einstein once remarked, "Only two things are infinite: the universe and human stupidity, and I am not sure about the former." His humor hides a deep truth, that infinity is not simply large, it is fundamentally incomprehensible. And then there is the most unsettling possibility of all, that our entire cosmic history might be the rendered surface of deeper information processes, a suggestion found in the simulation hypothesis. If the cosmos can expand, encode, store, and evolve information over billions of years, then perhaps reality itself is a kind of unfolding computation. Some see this as far-fetched, others as inevitable. As physicist John Wheeler once said, "It from bit," the idea that every particle, every field, every law of nature arises from acts of information. And if this is true, then consciousness itself may not be a passenger of cosmic history, but a participant. Perhaps this is where cosmic consciousness finds its home, in the quiet interplay between information, perception, and the expanding fabric of space. As I reflect on these ideas, I am struck by how the universe balances simplicity and mystery, clarity and wonder. We know so much, yet the horizon keeps moving, retreating like a wave from the shore. And perhaps that is the lesson hidden in cosmic history. The universe does not ask us to understand it completely. It asks us to follow its questions, to be humble before its scale, and courageous before its mystery. To accept that knowledge has boundaries, but curiosity does not. We live in a universe that expands beyond sight, beyond reach, and perhaps beyond reason. Yet we also live in a universe that allows tiny sparks of awareness to wonder about it, to question it, to love its mystery. That is our place in cosmic history, not as observers at the edge of infinity, but as minds capable of touching it. When we speak about matter and energy in the universe, we are not speaking about familiar things, not the weight of a stone in our hand, not the warmth of sunlight on the skin, but about a deeper shadowed architecture that supports everything without ever revealing its true shape. For all our telescopes and theories, for all our equations carved like constellations onto the blackboard of human knowledge, the staggering truth remains that 95% of the universe is made of something we do not understand. Dark matter and dark energy, the twin mysteries that cradle the cosmos in silence, form the unseen backbone of existence, the invisible script written beneath the story of the stars. Physicist Vera Rubin once said, "We see the motions of the galaxies, but we do not see what moves them." Her words echo across decades, still as haunting, still as beautiful as the first time she described the rotational curves that changed cosmology forever. When we first observed galaxies whipping around their centers, spinning far faster than their visible mass should allow, we were forced into a revelation. Either the laws of gravity were broken, or something unseen was holding galaxies together. This invisible substance became known as dark matter, not because it is dark, but because it hides from every instrument we possess. It does not shine. It does not absorb. It does not scatter light. It operates like a quiet guardian, shaping the skeleton of the universe while remaining completely unknown. And yet, we can see its fingerprints. We see it in the rotation of galaxies, in the way clusters of galaxies bend light passing through them, in the delicate ripples of temperature frozen in the cosmic microwave background. All of them whisper the same message, that something unseen outweighs the stars themselves. Dark matter is the scaffolding upon which galaxies form, the stage upon which cosmic evolution unfolds. Without it, galaxies would fly apart like fireflies scattered in the wind. As astronomer Jim Peebles put it, we live in a universe dominated by dark matter and only slightly illuminated by light. Yet even dark matter, mysterious as it is, accounts for only a portion of the invisible universe. The greater mystery is dark energy, the force responsible for accelerating the expansion of the cosmos. In the late 1990s, when astronomers measured the distances to remote supernovae, they expected to find a slowing universe. Gravity should have been pulling everything back, together, like a tired breath ready to inhale again. Instead, the universe was not slowing. It was speeding up. It was as if an invisible wind was blowing between the galaxies, a gentle but persistent pressure stretching the fabric of space itself. This became known as dark energy, though the name explains nothing. Einstein once introduced the idea of a cosmological constant, a pressure inherent to space, a kind of energy associated with emptiness itself. He later called it his greatest mistake. Then the universe revealed he had been right all along. Dark energy now dominates cosmology, shaping our ultimate future. It is the quiet breath that drives galaxies apart, the reason the night sky will one day grow emptier, colder, quieter than we can bear to imagine. And through all of this, ordinary matter is less than footer, us. The atoms of stars, the dust of planets, the molecules that compose human hands and human dreams is only 5% of existence. 5%. a fraction so small that if the universe were a symphony, we would be hearing only the faintest distant notes. Neil deGrasse Tyson once said, "We are stardust organized to contemplate the cosmos." But in truth, we are stardust, embedded in a vast ocean of something else entirely. Why does ordinary matter make up so little? The answer may lie in the earliest moments of the universe. In the delicate balance of creation during the first seconds after the Big Bang. Most of what existed then was energy, pure, high frequency, and only a portion cooled into the particles we now call matter, while dark matter and dark energy emerged from processes we barely comprehend. Some theorists believe dark matter may be a relic of symmetry breaking, a shadow of particles that did not join the familiar family of protons and electrons. Others suspect dark energy may arise from the quantum vacuum, the restless bubbling of space at its smallest scale. But after decades of theory and experiment, we still stand before the unknown. This is where the nature of the universe becomes philosophical, where physics begins to resemble poetry. When 95% of reality is invisible, when it passes through our instruments like mist through fingers, we are forced to confront the possibility that our deepest understanding has only scratched the surface. The limits of knowledge become part of the story. Boundaries not of space, but of human comprehension. The cosmos may not be incomprehensible, but it may require new forms of thought, new mathematics, new ways of seeing energy and space as partners in a dance that transcends intuition. Some scientists turn toward particle physics, searching for dark matter in underground detectors. Some analyze the large-scale structure of the universe, hoping to find the telltale patterns of dark energy's gentle push. Others whisper the possibilities of new dimensions, new fields, even new universes. A few venture further, suggesting that the unseen 95% may hold the key to something even stranger: the emergence of cosmic consciousness. If dark energy is woven into empty space, and dark matter shapes the structure of galaxies, then perhaps consciousness, in some subtle way, emerges from the same hidden fabric. This is speculation, yet it touches a profound intuition that the universe is not merely physical, but experiential. And there are even bolder ideas, that the missing 95% may hint at deeper layers of reality like those proposed in the simulation hypothesis. That our universe may be a rendered surface, a visible projection of invisible code. This does not diminish the importance of our lives. It elevates them. For if the universe contains hidden architecture, unseen forces, subtle frameworks, we are part of that architecture. We are the luminous thread running through the dark fabric, the spark that looks back at the night sky and asks why. As I reflect on the nature of matter and energy, I am filled not with despair but with awe. That the universe has allowed us to learn even a little, to peel back even one corner of the cosmic curtain, is a gift beyond measure. The great lesson here is humility and courage. Humility to accept that most of the universe lies beyond our senses, and courage to continue asking into the darkness. The cosmos is patient. It reveals itself slowly, like the tide receding to show patterns in the sand that were always there. We are allowed to witness only fragments. Yet, even those fragments are enough to transform us. Perhaps the universe hides 95% of itself not to frustrate us, but to invite us, to keep us searching, questioning, wondering, to ensure that curiosity remains the most powerful force we possess. In the vast dark ocean of what we do not know, the light we carry matters even more. When we look toward the future of the universe, we are not looking at a distant calendar. We are looking at the fate of time itself. The cosmos breathes in silence, expanding with every passing heartbeat of existence, carrying galaxies farther apart in a slow, majestic drift that has lasted for nearly 14 billion years. And in this long unfolding, the question rises like the first star of evening. Where is the universe going? Cosmologists believe that cosmic expansion is not slowing. It is accelerating. Something hidden in the fabric of space, something we call dark matter and dark energy, is pushing galaxies apart faster and faster. Stephen Hawking once said, "The greatest enemy of knowledge is not ignorance but the illusion of knowledge." And dark energy is the clearest example of how true that is. While dark matter shapes the cosmic web structure, dark energy shapes the future. It acts like a quiet pressure, woven into the emptiness of space, gently accelerating the expansion of the observable universe. As this acceleration continues, galaxies drift farther away, their light stretched into longer and longer wavelengths until it fades beyond perception. One day, billions of years from now, the night sky will be mostly empty. Not because the stars have vanished, but because their light can no longer reach us. This is the slow, quiet consequence of cosmic acceleration, a future where the universe becomes dimmer with each passing age. Physicist Lawrence Krauss once remarked, "Eventually, space will expand so quickly that distant galaxies will disappear from view." His words are not metaphor, but destiny. But there is a darker possibility, a scenario whispered among cosmologists measuring the strength of dark energy. This is the Big Rip, a future where acceleration does not merely continue, but grows uncontrollably. If dark energy increases with time, even by the smallest degree, then the expansion of the universe will become violent. Galaxies will be torn apart, then star systems, then planets. The gravitational bonds that hold atoms together will fail, and even the fabric of space-time itself will unravel. It is a haunting vision, a cosmic autumn in which every leaf of reality falls away. Yet, despite its poetic terror, most observations today suggest the universe is headed toward a gentler fate. A slow, deep cold. A future where galaxies fade beyond the cosmic horizon, where even light can no longer bridge the distances that expansion has carved. The cosmic horizon is the boundary of what we can ever know, a shifting edge where possibility dissolves into silence. Beyond that horizon, the universe continues, but it becomes forever unreachable. Brian Greene described this fate by saying, "Most of the universe will forever remain outside our grasp." The thought is both humbling and strangely peaceful. As the future unfolds, as galaxies fade from sight, we will eventually find ourselves in cosmic isolation. Our descendants, if they exist, will live beneath a sky that no longer tells the true story of the universe. They will not see clusters of galaxies, or superclusters, or the web of filaments that reveal how space once grew and stretched through Big Bang inflation. They will live inside a bubble of stars, believing themselves alone. And this is why modern cosmologists often say, we live in the only era where the universe is truly knowable. The present moment, this cosmic instant in which galaxies are still visible, is our one chance to study the true nature of the universe. 1 trillion years from now, the evidence of cosmic expansion, dark energy, and the multigalactic universe will be gone. Future astronomers will see a sky that lies, not intentionally, but inevitably. They will no longer see evidence of the cosmic scale, the filaments of the cosmic web structure, or the distant glow of galaxies that now define the observable universe. Their view will shrink, and with it, the truth of cosmic history. This is the most profound paradox in cosmology. The universe is becoming less knowable as it ages, not more. And so, we find ourselves in a golden era, the only window in which intelligent life can truly understand the cosmos. As physicist Adam Rees said after discovering dark energy, the universe is teaching us now because it knows it will one day fall silent. When we consider this future, we are invited to contemplate not only the fate of galaxies, but the fate of knowledge itself. What does it mean to learn in a universe that grows darker with time? What does it mean to observe when observation has an expiration date? Here, the story of cosmology becomes the story of humanity. To understand the universe is to understand ourselves, our fragility, our curiosity, and our desire to find meaning in the sweeping expansion of space. Some theorists turn to infinity in cosmology, asking whether cosmic expansion extends into realms beyond imagination. Others consider multiverse theory, wondering whether our fate is only one chapter in an endless library of universes. And a few explore the edges of thought itself, suggesting that cosmic evolution may lead toward a form of cosmic consciousness. This is where the physics touches philosophy, where mathematics touches meditation. As we move deeper into the future, the universe does not simply expand. It transforms our relationship to reality. If galaxies drift forever away, if the sky dims, if the evidence of cosmic birth fades below the cosmic horizon, we may be left with questions that cannot be answered. This brings us again to the limits of knowledge, not as a defeat, but as a companion to curiosity. The universe invites us to learn, but it also invites us to wonder. And in that wonder, we find something deeply human. The desire to understand a cosmos that will outlive us by trillions of years. As I reflect on the future of the Smite universe, I am filled with a mixture of humility and awe. The universe may end in darkness, but our ability to illuminate its mysteries is a light of its own. The lesson that emerges is gentle and profound. we live at the precise moment when the cosmos reveals itself. When galaxies are still visible, when the evidence of creation is still written in the sky. We are the fortunate witnesses, standing at the threshold between the universe that was and the universe that will be. In this passing era, the cosmos speaks in light. But one day, light itself will fall silent. And that is why now, more than ever, our curiosity matters. In the vast, quiet future ahead, the questions we ask today may be the last true echoes of a universe that once revealed its secrets under a sky full of stars. When we speak of consciousness in the universe, we step quietly into a realm where science and wonder breathe the same air. For billions of years, the cosmos expanded in silence, drifting outward through the long currents of cosmic expansion, shaping stars and galaxies and the vast cosmic web structure that holds the sky together. And then, in one small corner of the observable universe, awareness opened its eyes. Why did consciousness appear now, at this precise moment in cosmic time? Many cosmologists believe it is no accident, no coincidence. If humanity had emerged a few billion years earlier, the universe would have been too young, too dense, too chaotic to interpret. If we had arrived a trillion years later, the galaxies would have drifted beyond the cosmic horizon, leaving behind a dark sky with no clues to our origin. We exist in the only cosmic epoch where the universe allows itself to be understood. The fragile golden moment when starlight still carries information from the era of Big Bang and inflation. This idea is not merely poetic, it is scientific. As astrophysicist Ethan Siegel said, "If intelligent beings arise too late in cosmic history, they will never discover the truth about the expanding universe." But the deeper mystery begins when we ask whether consciousness is just a product of biology, or whether it is woven into the very structure of reality. Some scientists propose that awareness may be a fundamental feature of the universe, a kind of cosmic ingredient as real as space, time, and dark matter and dark energy. This line of thought touches the edges of infinity in cosmology, the idea that mind may arise wherever complexity blooms. Here, the universe becomes more than a physical machine. It becomes a place where information flows, where patterns form, where self-reference evolves naturally from the interactions of matter. This is why theoretical physicist David Bohm once said, "Mind and matter are two aspects of one deeper reality." The question then deepens. Could the universe be becoming aware through us? Carl Sagan gave voice to this idea when he said, "We are a way for the cosmos to know itself." Words like these linger because they resonate with something inside us, something ancient, something that feels like a memory older than life. When we look at the cosmic web structure stretching across billions of light years, glowing with clusters and filaments, we cannot help noticing its resemblance to neural networks in the human brain. In both systems, energy flows along branching pathways. Nodes light up with interaction. Structure emerges from connection. Franco Vazza and Alberto Folletti measured these similarities and found that the cosmic web and the brain share nearly identical patterns of information distribution, i.e., discovery that shakes the boundary between the inner world and the outer cosmos. If structure repeats across scales, perhaps consciousness does too. Could awareness exist in faint, primitive forms at the quantum level, or symbolic forms at the galactic level? Not in the sense of thought, but in the sense of response, adaptation, self-organization. Quantum fields ripple with information. Atoms interact in elaborate dances. Stars sense their environments through fusion and gravity. Galaxies feel the gravitational currents of their neighbors, responding to the silent architecture of dark matter and dark energy. Some cosmologists believe these patterns hint at a universal tendency toward awareness, a rising complexity that culminates in the reflective consciousness of beings like us. Others push further, suggesting that reality itself might depend on observation, a view echoed in John Wheeler's famous phrase, "The universe does not exist without observers." In this perspective, consciousness is not a side effect of matter, but part of the relational structure that allows the universe to manifest. This concept appears again in the simulation hypothesis, where observers are essential for rendering the universe's visible layers. Without observation, information remains dormant, like a hidden script waiting for light to reveal it. And yet, no matter how deeply we explore these ideas, we eventually collide with the same silent wall: the limits of knowledge. We can analyze consciousness in the brain, but not in the quantum foam. We can measure dark matter's gravitational influence, but not its identity. We can calculate the expansion of space, but not the deeper purpose behind it. Perhaps the greatest truth is that consciousness and the universe are intertwined in ways we are only beginning to sense, like two melodies woven into the same cosmic song. As I reflect on these ideas, I am struck by the thought that consciousness may be the universe's most astonishing creation, not because it is rare, but because it allows the cosmos to look inward. Through human eyes, starlight becomes memory. Through human thought, the expanding universe becomes a question. Through human awareness, the cosmos achieves a moment of self-reflection. This is not mysticism. It is the consequence of a universe that produces observers capable of interpreting it. So when we ask whether the universe is becoming conscious through us, the deeper question may be whether consciousness is the natural flowering of the universe's inherent complexity. If awareness is the universe awakening, then every moment of curiosity, every question about reality, every quiet wonder beneath the night sky becomes an act of cosmic self-recognition. And this leads to the final question: does consciousness exist at all levels of reality? Not as thought, but as pattern, response, coherence. The universe organizes itself across quantum fields, planetary atmospheres, galactic clusters, and in us, that organization becomes aware of itself. In that sense, consciousness is not merely human, it is cosmic. It is the echo of a universe learning to feel its own existence. The lesson I draw from all this is gentle but profound: that we are not separate from the universe we study. We are part of the very process that makes study possible. We are made of matter born in stars, shaped by forces older than galaxies, carried through time by cosmic expansion. And now, for a brief moment, consciousness flickers across the dark fabric of space-time. Perhaps it is not that humans appeared at the right time to understand the universe, but that the universe has reached the right moment to be understood. In our awareness, the cosmos awakens. When we speak of infinity in the universe, we step into a territory where logic bends softly like starlight passing near a black hole. Infinity is not a number. It is not a place. It is not even a concept the human mind was built to contain. And yet, when we explore the cosmic scale of the observable universe, infinity becomes impossible to avoid. Scientists have always known that trying to calculate infinity is like trying to hold the ocean in your hands. As the mathematician David Hilbert once said, "Infinity is nowhere to be found in reality. It is a beautiful idea that leads to contradictions everywhere." The moment you attempt to add infinity to an equation, the universe refuses to answer. Probabilities break. Logic dissolves. Certainty evaporates like frost under morning light. Because infinity is not something you calculate. It is something you confront. When we apply infinity to cosmology, to infinity in cosmology and the large-scale structure of space, the questions grow even stranger. If the universe is infinite, then everything that can happen must happen. Not once, not twice, but an infinite number of times. Somewhere in the immeasurable reaches beyond our cosmic horizon, there may be a galaxy identical to the Milky Way, a star identical to the Sun, a world identical to Earth. And on that world, another version of you may be sitting quietly, breathing in the same cosmic questions. Max Tegmark once said, "If space is infinite, then you have an infinite number of doppelgangers." His words are unsettling, yet mathematically unavoidable under certain models of cosmic expansion. But infinity does more than replicate worlds. It breaks the very idea of probability. If you flip a coin in an infinite universe, there are infinite outcomes, infinite configurations, infinite histories in which the coin lands both heads and tails an infinite number of times. Probability relies on limits, but infinity erases limits. This is why cosmologist Sean Carroll once said, "Infinity is where physics goes to die." In an infinite universe, the rare becomes inevitable. The impossible becomes routine. Even the idea of individuality begins to dissolve. Because if there are infinite versions of you, if every possible variation of your life exists somewhere, what does it mean to be you? Infinity challenges the deepest foundations of personal identity. Yet, infinity is not just a philosophical puzzle. It is woven into the physics of Big Bang and inflation, which may have produced an infinite number of cosmic domains during its brief and explosive expansion. Inflation stretches space so fast, so violently, that entire regions become forever disconnected. These disconnected bubbles form the basis of multiverse theory, a grand cosmic quilt where different universes expand independently like glowing islands scattered across an endless ocean. Some universes may have different constants. Some may have different forms of matter. Some may collapse quickly, while others expand eternally. In this vastness, our universe may be one chapter in a book with infinite pages. The cosmic web structure also hints at infinity, stretching beyond what our instruments can see. A pattern that may continue endlessly, weaving galaxies into filaments larger than imagination can process. Even dark matter and dark energy carry the shadow of infinity, shaping the fate of the universe on scales that stretch into regions we will never observe. Beyond all horizons, beyond all known physics, infinity stands like a quiet curtain hiding the deeper structure of reality. Some physicists suggest that infinity may be a sign we are asking the wrong questions, that space may be finite yet unbounded, like the surface of a sphere made of higher dimensional geometry. Others argue that infinity is necessary, especially in the context of the simulation hypothesis, where limitless computational space or recursion loops could produce an endless variety of outcomes. John Wheeler hinted at this when he said, "Reality is built from acts of observation. If each observation collapses possibilities into experience, then in an infinite universe, every possibility becomes real somewhere." Infinity forces us to confront the limits of knowledge, the idea that some answers may remain forever outside the reach of finite minds. And yet, infinity also expands our sense of what consciousness can be. If awareness arises naturally from complexity, and if complexity appears across many scales, then perhaps cosmic consciousness is not a fantasy, but the culmination of infinite patterns finding self-reflection through experience. As consciousness looks outward, contemplating the infinite, it becomes part of the infinite looking inward. This is why Carl Sagan's words feel truer now than ever. We are a way for the cosmos to know itself. Infinity forces us to see ourselves as threads in a much larger tapestry, not isolated minds, but expressions of the universe folding back onto itself. My own belief is that infinity is not meant to be solved. It is meant to humble us. Infinity teaches patience, because not all answers arrive. Infinity teaches reverence, because we are small. Infinity teaches wonder, because even small minds can imagine endlessness. And perhaps that is the most human thing of all. In a cosmos filled with unreachable horizons, in a universe shaped by forces we cannot touch, in a multiverse that may contain countless variations of our story, we still sit quietly under the night sky and dare to imagine the infinite. Infinity does not make us insignificant. It makes us miraculous. For in a universe that may contain infinite possibilities, there is only one you who is here, now, contemplating it. When we begin to speak of the multiverse, we step into the soft twilight where science brushes gently against imagination. This realm is not only vast on the cosmic scale, it is perhaps unending, perhaps layered, perhaps branching like an infinite cosmic forest where each tree grows its own sky. The idea begins quietly with Big Bang and inflation, not the explosion people imagine. but the sudden stretching of space in the universe's first breath. Inflation expanded the newborn cosmos faster than light, smoothing it, sculpting it, creating pockets of space that inflated and froze into existence. Physicist Alan Guth, father of inflation theory, once said, "Inflation is not something that ends everywhere at once." Those few words unclasped the door into multiverse thinking. Inflation may stop in some regions, allowing them to become universes like ours, but it may continue endlessly in others. This gentle but eternal growth is known as eternal inflation, a process that naturally creates countless cosmic bubbles. Each bubble universe inflates from quantum fluctuations. Each one expands and cools on its own timeline. And each one becomes a universe isolated from all others by stretches of inflating space that grow faster than any signal can cross. Inside each bubble, the laws of physics may solidify differently. Some may have stronger gravity, some weaker. Some may ignite stars quickly. Others may never form atoms at all. Perhaps this is why our universe contains just the right mixture of dark matter and dark energy, just the right particle masses, just the right conditions for stars and life to arise. If eternal inflation is true, then we live in one of countless possible universes, each born from the same cosmic storm. And so we ask the natural question: is there a universe identical to ours? If space or possibility is infinite, then mathematically the answer may be yes. Beyond our cosmic horizon, somewhere in the broad, silent sea of existence, there could be a region where the arrangement of atoms mirrors our own. A planet like Earth, a city like yours, a life like the one you're living right now. Max Tegmark expressed this idea simply: in an infinite cosmos, identical copies of you exist. This idea is unsettling, yet it grows naturally from infinity in cosmology. In an infinite set of universes, every possible story is written. Every variation unfolds. Every path branches into countless new ones. Like a fractal made of realities rather than shapes. But this is more than mathematics. It is also a question of identity. If another version of you exists, identical in every way, then what does it mean to be you? Are you unique? Or are you one thread among many woven into the same cosmic tapestry? In the multiverse, individuality becomes both precious and fragile. Some scientists believe the multiverse may be far stranger than endless copies. They suggest each universe could exist with entirely different physics, different quantum rules, different unfolding histories. As physicist Leonard Susskind said, the multiverse might be the ultimate expression of nature's creativity. In this vision, the multiverse becomes a cosmic coral reef of laws and realities, blooming into infinite variations. But then, a question emerges from the darkness. Can the multiverse be proven? Our observable universe is bounded by the cosmic horizon, a limit beyond which no information can reach us. This horizon is not the edge of reality, but the edge of our knowledge, the regions beyond. The countless bubble universes predicted by multiverse theory, are expanding away faster than light can cross the distance. We cannot reach them, cannot see them, cannot communicate with them. This is where the limits of knowledge rise like a misty wall, soft but absolute. Some scientists argue the multiverse is untestable, and therefore not science. Others believe indirect traces may exist, perhaps hidden in the cosmic microwave background. Gentle bruises where two universes might have collided in their infancy. Still others consider that the multiverse may reveal itself through the unexplained fine-tuning of physical constants, suggesting our universe is one that just happens to allow life to emerge. And then there is an even stranger idea, that the multiverse may be an artifact of the simulation hypothesis, that countless universes are simply computational branches in a deeper informational structure. John Wheeler's words return once more. We are participants in the creation of reality. Whether he meant this literally or metaphorically, the line between physics and perception becomes thinner and softer when infinite universes enter the conversation. As I reflect on all of this, I find myself humbled by the elegance of possibility. The multiverse may exist, or it may not. But the ideas it inspires tell us something profound about ourselves. They tell us that curiosity has no horizon, that imagination stretches farther than the largest galaxy, that the mind can wander beyond the known cosmic web structure into realms of potential and dream. The lesson hidden inside the multiverse is not about physics alone. It is about perspective. If infinite universes exist, then our world is both insignificant and irreplaceable. If infinite versions of us exist, then this moment, this life, this awareness remains uniquely ours. Infinity does not diminish us. It deepens us. In a cosmos where reality may branch endlessly, meaning is not found in being the only version of ourselves, but in being the conscious one, the observing one, the one who knows the universe is vast enough to contain infinite possibilities and still chooses to wonder. Whether the multiverse exists or not, the human mind has already touched it. And perhaps that is the point. When we look at the universe on its largest scales, when we trace the glowing filaments of the cosmic web structure stretching across billions of light years, we feel a strange familiarity. These immense threads of galaxies, these knots of stars and dark matter, lie scattered through space in patterns that resemble something deeply intimate to us. They look like the neural pathways of the human brain. Two systems that differ by 60 orders of magnitude, yet shaped by the same quiet mathematics of connection and flow. Franco Vazza, an astrophysicist, and Alberto Faletti, a neuroscientist, found that the structure of the observable universe and the human cortex share nearly identical patterns of complexity, as if the universe and the brain were built from the same blueprint. This resemblance leads to a profound question, whispered across science and philosophy alike. Could the universe itself be conscious? To ask whether the universe can think is not to imagine it with a mind like ours, but to ask whether consciousness arises naturally when matter reaches a certain level of organization. If consciousness is an emergent property of complexity, then what happens when complexity spans the cosmic scale? Michio Kaku once said, Consciousness is the process of creating a model of the world in order to achieve a goal. If that is true, then the question becomes deeper. Does the universe create models of itself? Through us? Perhaps it does. Carl Sagan captured this idea in one sentence. We are a way for the cosmos to know itself. Not metaphorically, but literally. Human awareness arose only after billions of years of cosmic expansion, after stars forged elements in their cores, after planets formed in the gentle swirl of dust, after life evolved. We are the universe's memory, the universe's witness, the universe's reflection on its own existence. This does not imply the universe has thoughts, intentions, or desires. But it suggests that consciousness may not be separate from the cosmos, but a natural phase in its evolution. After all, the atoms in your brain were made in stars, shaped by dark matter and dark energy, carried outward by Big Bang and inflation. When a person thinks, it is not only the brain thinking, it is the universe thinking through the brain. Some thinkers go further, asking whether vast structures like galaxies could possess primitive forms of awareness. Not thoughts, but responsiveness, coherence, a kind of information processing that mirrors the earliest stages of mind. This is speculative, yet not entirely unreasonable. If consciousness emerges from complexity, and if complexity exists across scales, then why should mind be confined to neurons? Galaxies respond to gravitational tides, adapt to dark matter halos, exchange energy across aeons of time. Is that thought? No. Is it proto-thought? A faint cosmic precursor to awareness? Perhaps. The idea echoes David Bohm's belief that mind and matter are two aspects of one deeper process. And if the universe is a process that generates consciousness, then consciousness may be more deeply connected to the cosmos than we realize. This idea also appears in the simulation hypothesis, where consciousness is the core interpreter of information. If reality is in some sense computational, then observers and the observed are intertwined. In that view, consciousness is not passive. It actively participates in shaping the universe's appearance. But how far can this idea be taken? Can the universe truly be seen as an enormous mind? To say the universe thinks is poetic, but perhaps not literal. The universe does not form sentences, does not plan, does not dream as we do. But the universe forms complexity, forms patterns, forms awareness in beings capable of self-reflection. In this sense, we are not separate from a cosmic mind. We are its living neurons. Just as the brain produces thought through the interaction of billions of cells, the universe may produce awareness through the interaction of billions of minds. This is what some call cosmic consciousness. A universe that becomes aware of its own shape, its own history, its own destiny. And yet, even as we explore these ideas, we confront the limits of knowledge. We cannot measure consciousness in stars, cannot detect awareness in galaxies, cannot prove that the universe thinks. But what we can measure is connection, structure, information flow. The universe organizes itself in ways that mirror the growth of mind. This alone suggests something extraordinary, that consciousness is not opposed to the universe, but aligned with it. As I reflect on these questions, I feel a gentle realization forming. Consciousness is not an accident. It is a stage in cosmic evolution. The universe spent billions of years cooling, expanding, creating structure, building complexity. Stars gave birth to atoms. Atoms gave birth to chemistry. Chemistry gave birth to life. Life gave birth to awareness. And awareness gave birth to curiosity. Through curiosity, the universe observes itself. Through wonder, the universe reflects on itself. Through human consciousness, the universe achieves a moment of self-understanding. The lesson in this is gentle but profound. We are not outsiders looking at the universe. We are expressions of the universe looking at itself. A galaxy cannot think. A star cannot dream. But through the fragile miracle of consciousness, the cosmos learns what it is like to exist. And perhaps that is the quiet purpose behind all cosmic evolution: to create beings capable of wonder. In our awareness, the universe awakens. When we begin to question the nature of reality, we step into a quiet region of thought where the universe becomes not just a place, but a riddle whispered across the dark. The stars shimmer like clues scattered over the cosmic scale, and the silent architecture of the observable universe seems to invite us closer, urging us to wonder whether what we see is truly what exists. In this stillness, one of the most astonishing ideas emerges: the holographic principle. The suggestion that everything we touch, everything we feel, everything that fills our three-dimensional world, may actually be a projection of information on a distant two-dimensional boundary. Leonard Susskind, one of its greatest defenders, once said, "The world looks three-dimensional, but its deepest description may live on a cosmic screen far away." If this is true, then reality is not solid, not fundamental, but something like a cosmic illusion. The universe no longer resembles a vast physical stage, but a shimmering hologram projected from the edge of space. This idea springs naturally from black hole physics, where information seems to live not in the volume of the hole, but on its surface. If black holes store information holographically, perhaps the entire cosmos does too. This leads to another thought, equally unsettling, equally beautiful. What if our universe itself is inside a black hole? In this vision, the Big Bang and inflation were not the birth of all things, but the moment our cosmic region formed inside the event horizon of another universe's collapse. Physicist Nikodem Popovsky proposed that every black hole could give birth to a new universe, a self-contained realm where time begins anew on the other side of gravity's deepest well. If this is true, then our cosmic horizon is not the limit of space, but the inner surface of a larger dimensional boundary. A doorway we cannot cross, but one that might connect us to an older universe outside our own. Even more startling is the symmetry of it. If universes emerge from black holes, then perhaps the universe that produced ours was itself born from another. And so on. Unfolds a cosmic ancestry that stretches beyond imagination. Yet perhaps the most provocative idea of all is the one that feels strangely familiar to our digital age: the simulation hypothesis. The idea that reality might be a vast computational construct, more like a program running on an unimaginable substrate than a physical world made of particles. Nick Bostrom famously argued, "We are either the first intelligent civilization in the universe, or we are almost certainly living in a simulation." If advanced civilizations can simulate conscious beings, and if simulations vastly outnumber physical worlds, then statistically we are more likely to be simulated than real. In such a universe, the laws of physics become rules of computation. The constants of nature become parameters, and quantum random events become the noise of calculation. But even if the universe is a simulation, the question remains: who wrote the code? Some suggest it could be beings existing in a universe higher within the stack. Others suggest it could be an emergent process, an automatic generation of realities across multiverse theory. John Wheeler's idea returns to us here. It from bit. The notion that information lies at the heart of all physical reality. If everything is information, then perhaps there is no fundamental divide between simulation and physical universe. Perhaps both are expressions of a deeper informational truth. Yet the simulation hypothesis carries a quiet paradox. The reason we cannot disprove it is because any evidence against it could itself be part of the simulation. This leads to an unsettling but enlightening truth. We cannot prove we are in a simulation, and we cannot prove we are not. This is where physics reaches the limits of knowledge, the boundary where science becomes philosophy, and philosophy becomes meditation. For if the universe is a hologram, or a black hole, or a simulation, or a layer in an infinite hierarchy of realities, what does that mean for us? It means that existence itself is deeper, richer, more mysterious than any one model can describe. It means awareness is precious, because through awareness, the cosmos becomes more than equations. It becomes experience. And here the idea of cosmic consciousness emerges softly, like a sunrise over ancient hills. If consciousness is not separate from the universe, but a natural unfolding of its complexity, then every model of reality, holographic, simulated, or cosmic, becomes part of the same truth. We are not outside observers. We are participants. We are not strangers in a meaningless cosmos. We are expressions of the universe's own ability to recognize itself. As I reflect on these ideas, I find that the question is not which model of reality is correct, but what these models reveal about the bond between consciousness and the universe. The universe might be a hologram, yet your thoughts are real. The universe might be inside a black hole, yet your awareness shines like a star. The universe might be a simulation, yet your experiences give it meaning. This is the lesson that hums beneath all these theories. Reality is not defined by its mechanics, but by the consciousness that perceives it. Whatever the universe truly is, we are the ones who bring it to life. In the quiet space between stars, in the gentle hum of cosmic expansion, in the shimmering patterns of the cosmic web structure, consciousness listens, and in listening, becomes one with the universe it seeks to understand. Perhaps that is the ultimate truth behind all these models. We do not merely live in the universe. The universe lives in us. When we begin to contemplate the limits of knowledge, we enter a quiet frontier of the universe, a place where our instruments fade, where light grows thin, where questions float like dust in the eternal dusk of the cosmic scale. This frontier is not defined by distance alone, but by the structure of reality itself. There are regions of the observable universe we will never see, not because they lack stars, but because the universe expands faster than their light can reach us. Beyond the cosmic horizon lies a realm forever hidden, a silent ocean of galaxies that drift beyond communication. Brian Greene once said, "Most of the universe will forever remain outside our grasp." His voice held no sadness, only reverence. When we gaze into the night sky, we are not seeing the universe as it is, but the universe as it was. The further out we look, the further back in time we travel, until eventually we reach a wall of light. The cosmic, microwave background, the last surface we can observe directly. Everything before it, every moment between the Big Bang and inflation, is hidden behind a veil that no telescope can pierce. Our knowledge is shaped by illumination, and illumination only reaches so far. This raises a haunting question, whispered softly across cosmology. Is everything we see merely a fraction, the smallest visible petal, of a universe far larger than we imagine? Many scientists believe so, not out of speculation, but because the mathematics of cosmic expansion almost demands it. The observable universe is like a lantern in a vast cavern, lighting only a small circle around us, while the darkness extends endlessly beyond. On the largest scales we can measure, the cosmic web structure stretches like a network of luminous rivers, connecting clusters and superclusters in patterns older than galaxies themselves. But what lies beyond superclusters? Beyond the cosmic web we can see? The truth is simple and humbling. We do not know. Perhaps there are megastructures of cosmic filaments whose sizes dwarf our greatest superclusters. Structures too large for our light to trace. Perhaps the universe transitions into new phases of matter and energy across distances we can never measure. Perhaps the grand patterns we see are only the first few threads of a tapestry that extends far beyond the horizon. The mathematician Hermann Bondi once said, "It is not surprising that the universe is strange. What would be surprising is if it were not." The strangeness deepens when we consider dark matter and dark energy, the invisible scaffolding and silent expansion that shape everything yet remain unknown. If 95% of the universe is invisible to us, then perhaps our view of reality is not only narrow, but profoundly incomplete. We may be the inhabitants of a cosmic island, surrounded by an ocean of information we cannot touch. This limitation is not only physical, it is philosophical. Even if we traveled at the speed of light, even if we unlocked the secrets of quantum travel, even if we mastered the geometry of space-time, there would still be regions forever beyond reach. And so we ask another question, one that stirs quietly in the background of every scientific breakthrough. Is science chasing a horizon it can never reach? Every time we push the boundaries of understanding, the horizon moves. When we discovered atoms, we found quarks. When we discovered galaxies, we found clusters. When we discovered the cosmic web, we glimpsed superclusters and structures beyond imagination. Knowledge expands, but so too does the frontier of the unknown. This is why Einstein once said, "The more I learn, the more I realize how much I do not know." Our understanding grows, but the darkness around it grows faster. This does not diminish science, it dignifies it. For the purpose of science is not to reach the end of knowledge, but to expand the circle of light in a universe where darkness is infinite. There are theories in multiverse theory that the structures beyond our horizon may not be part of our universe at all, but entirely separate realms created by eternal inflation. There are models within infinity in cosmology suggesting that our observable domain is one bubble among infinite bubbles. There are hypotheses within quantum gravity indicating that space-time itself may have layers we have not yet imagined. And there are philosophers of science who argue that reality has depth, like a painting we have only begun to brush with color. The simulation hypothesis also appears here, suggesting that the limits of knowledge may be the limits of the simulation itself. That the cosmic horizon is not only physical, but computational. Nick Bostrom once wrote, "If we live in a simulation, the laws of physics may simply be rendering constraints. But whether the universe is simulated, holographic, or infinitely layered, one truth remains constant. Our curiosity pierces through the darkness." As I reflect on the limits of knowledge, I feel neither despair nor frustration. I feel awe and a sense of intimacy with the cosmos. The unknown is not a barrier. It is an invitation. The horizon does not tell us where to stop. It tells us where to look next. Every unanswered question enlarges the universe within us. The great lesson hidden in the limits of science is this: we do not seek knowledge to conquer the universe. We seek it to connect with it. The cosmos grows, darker with distance, but the human mind grows brighter with understanding. We may never know what lies beyond the cosmic horizon. We may never see the full architecture of reality. We may never grasp the final truth of existence. But we can stand beneath the stars, in this fleeting moment between birth and silence, and marvel that we were given the chance to wonder at all. And perhaps that is the purpose of knowledge. Not to reach the end of the universe, but to awaken the part of us that feels at home in its infinite mystery. When we speak about the meaning of human existence, we step into a quiet chamber of the universe, a place where the night sky does not simply shine, it listens, where stars are not merely distant suns, but mirrors reflecting the questions carried in our breath. On the cosmic scale, we appear impossibly small. A single species, on a single world, orbiting a modest star on the edge of a galaxy that itself is only one ripple in the vast cosmic web structure. But on the scale of awareness, on the scale of consciousness, we become something else entirely. Carl Sagan once said, "We are made of star stuff." Yet he also said, "We are a way for the cosmos to know itself." And in these two ideas lies the paradox of our existence. We are small, yet infinite. For billions of years, the universe expanded in silence, carried outward by the gentle breath of cosmic expansion, shaped by dark matter and dark energy, sculpted by cycles older than memory. Stars burned and collapsed, galaxies collided, clusters formed and drifted across the observable universe. And then, in one fragile moment, consciousness blossomed on a small blue world. We emerged not at random, but at the one cosmic period when the evidence of the beginning is still visible, when the sky still carries the echo of Big Bang and inflation. In this sense, humanity is not late and not early. We arrived at the exact moment the universe became knowable. This is why so many cosmologists believe our existence is deeply connected to the evolution of the universe itself. The physicist Paul Davies once said, "The universe is astonishingly bio-friendly in the narrow window where life can emerge and understand it." We are small, yes, but we hold something galaxies do not. We can ask why. We can wonder about the limits of the cosmic horizon. We can ponder infinity in cosmology. We can imagine universes beyond our own through multiverse theory. We can contemplate whether reality is physical, holographic, or part of the deeper framework suggested by the simulation hypothesis. We carry in our minds a capacity the universe took eons to prepare. And this leads to a profound thought. Perhaps we are not small. Perhaps we are precisely the scale at which the universe begins to notice itself. When we observe galaxies, measure cosmic background radiation, or calculate the behavior of quantum fields, the universe is not being studied by something separate from it. It is studying itself through us. This is the quiet essence of cosmic consciousness, not the claim that the universe thinks as a mind, but the recognition that the universe produces beings who think. Awareness is not an accident. It is an emergent property of cosmic complexity. And so we ask another question, perhaps the most human of all. What does it mean that we can contemplate infinity? Infinity humbles us, because it reveals how little we know. Infinity elevates us, because it reveals how far the mind can reach. We cannot travel beyond the cosmic horizon, but the mind can. We cannot see the birth of the universe, but the mind can imagine it. We cannot visit other universes if they exist, but our thoughts wander freely across the terrain of multiverse theory. To think about infinity is to stretch consciousness beyond the boundaries of physical existence. This ability is not trivial. It is extraordinary. As physicist John Archibald Wheeler said, "We are tiny patches of the universe looking back at ourselves." It is through us, not through stars, not through galaxies, that the universe becomes aware. And so the question arises. When we ask how large the universe is, are we really asking how far consciousness can extend? For the universe may be vast, unending, a labyrinth of galaxies threading through the dark. But consciousness has its own vastness. It can grasp the structure of atoms and the dance of electrons. It can imagine the first second after creation. It can build models of the infinite. In this way, the size of the universe is not only a physical measurement, but a reflection of the mind that contemplates it. We are shaped by stardust, yet capable of contemplating stars. We are born from the smallest particles, yet able to measure the largest structures. We are finite beings, yet able to conceive the infinite. This is the paradox of human existence. Small in form, vast in awareness. And when we ask about the meaning of our existence, perhaps the answer is hidden in the unity between mind and cosmos. The universe is large, but consciousness is what gives it scale. The universe is old, but consciousness is what gives it time. The universe is silent, but consciousness is what gives it voice. My own belief, formed through years of listening to the quiet conversations of the cosmos, is that meaning does not come from the universe itself. Meaning arises where consciousness touches the universe. The lesson hidden beneath 12 chapters of cosmic exploration is gentle and profound. We do not matter because the universe is aware of us. We matter because we are aware of the universe. It is not the stars that give us significance. It is our ability to feel astonished by them. It is not the cosmos that grants us purpose. It is our willingness to search for meaning within its infinite night. And so, the final question returns to us with a quiet glow. How big is the universe? Or how vast can human consciousness become? Perhaps these two questions are the same. For the boundaries of the universe may be unreachable, but the boundaries of the mind are expanding still. In this brief human lifetime, in this fragile moment between starlight and silence, we hold the extraordinary privilege of wondering at all. And perhaps that is the meaning of existence. Not to fully understand the universe, but to let the universe be understood through us. As we arrive at the end of this long journey through the cosmos, we find ourselves standing in a quiet place, halfway between wonder and understanding. We have drifted across the cosmic scale, listened to the echoes of Big Bang and inflation, followed the threads of the cosmic web structure, and gazed beyond the cosmic horizon into mysteries we may never reach. Yet through every chapter, one truth has risen gently, like a tide that returns in the dark. The universe is vast, but consciousness is what allows it to shine. We explored dark matter and dark energy, traced the possibilities of multiverse theory, and touched the quiet boundary where the limits of knowledge begin to blur into silence. And still, through all distances, through all infinities, one question has followed us like a faithful shadow. What does it mean to exist? Perhaps the meaning is not hidden in galaxies or equations, but in the simple act of looking up. For every time we wonder, the universe knows itself a little more. And every time we understand, consciousness expands farther than light can travel. In that sense, you are not small. You are the living bridge between the cosmos and its own reflection. And now, as we close this exploration, I want to speak to you directly. Thank you, truly, for walking this cosmic path with me. Thank you for your curiosity, your patience, your willingness to wonder in a world that often forgets to look up. May you carry the universe gently within you, and may your thoughts continue expanding long after the stars have dimmed. And until our next journey, keep wondering, keep asking, keep shining.